Okay, so let's finish up lesson 1-7. So this is what we've done so far. Okay, we know the interior angles of a triangle add up to 180 degrees. We looked at our exterior angle theorem. So the measure of angle 3 is equal to the measure of angle 1 plus the measure of angle 2. We classified triangles using a side length classification and an angle measure classification. And then we discussed the relationship between sides and angles. So a side and an angle are always opposite each other in the triangle. Angle B is opposite side length B. Angle A is opposite side length A. And then lastly, angle C would be opposite side length C. Oh, what am I doing here? Okay, so let's discuss isosceles triangles, which we did talk about with classifications. Okay, so this is in your notes. We know isosceles triangle is defined by two congruent sides. Okay, notice all the vocabulary. The vertex is where the two congruent sides meet. The base angles are the angles that are opposite the congruent legs. And then your vertex angle would be the vertex, would obviously be the angle formed at the vertex. Okay, notice we have our markings on there for our congruent legs. Okay, so familiarize yourself with what those markings look like on an isosceles triangle. Find the missing information in each triangle. Okay, let's start with this little guy here. I have this side is congruent to this side. So if this side length is 9, then it forces that side length to be 9. No other work is necessary. Okay. When I look at this triangle, RST, I know that it's isosceles because I see my base angles here are both 64 degrees. Okay. The only thing that tells me about my side lengths is that side RS would be congruent to side ST. Okay, so RS is congruent to ST. All right, angle measures don't tell me anything about the side, the length of the side themselves. It just tells me what sides it corresponds to. All right, so to find the measure of angle S, it's still a triangle. So the three angles add up to 180, and I'm going to subtract from that the sum of the two base angles, 64 and 64. So 180 minus 128 degrees. So that would give me 52 degrees for the measure of angle S. Okay, and then in the second triangle, we're missing a little bit of information here. If I tell you triangle ABC, or in triangle ABC, I know that AB is congruent to BC. So if I add that piece of information, AB is congruent to BC. I can put that in there. And now I have an isosceles triangle. Furthermore, I know that angle A has to be congruent to angle C. And why? These are my base angles. Okay, they're the angles opposite the two congruent sides. So now to find the measure of angle A, I can only subtract 120 degrees from the 180. It's the only angle measure I have. Okay, so when I get 60 degrees, well, if I know that A and C are the same, I'm just going to split A and that 60 degrees in half. So the measure of angle A is 30 degrees, and the measure of angle C has to be 30 degrees as well. All right, now equilateral triangles. So equilateral triangles, we know all three sides are congruent. Okay? If all three sides are congruent, all the angles have to be congruent as well. And I know the measure of each angle. Okay, so if the three angle measures add up to 180 degrees, I'm going to divide that by three congruent angles. The measure of each angle is 60 degrees. Okay, so these pieces of information we're going to continue to use them, so you have to make sure that when you have an equilateral triangle, you're aware that all three of these things are true. All right, find the length of each side in the given triangle. Okay, so my markings tell me that the triangle is equilateral. So if I'm given 15 centimeters as one length, I know 15 centimeters would have to be the measure of the other two lengths. Okay, now this triangle is interesting. So I know that it's equilateral based on the markings. So then in order to find the side length, I have to find the value of x. Well, if all three sides are equal, I can set up any equation relating two of the given sides. So if I just say AB is equal to BC, all right, I'm going to subtract 4x from both sides, and I get x is equal to 4. Okay, well, what if I want to set 6x equal to 3x plus 12? That's acceptable as well, because BC is congruent to AC. I'm going to subtract 3x from both sides, and again, I get x is equal to 4. Okay, well, how about 4x plus 8? What if I set that equal to 3x plus 12? So I'm going to subtract 3x from both sides, and then I'm going to subtract 8 from both sides. So no matter what equation you set up, we get the same value of x. Okay, so you don't need to show all three. You just need to set up one equation. But now we got to answer the question. Find the length of each side. Okay, well, let me plug x into my easiest expression, and I get 24. Okay, so each side length would better be equal to 24. When I plug 3 times 4 is 12. 12 plus 12, that gives me 24 here. 4 times 4 is 16. 16 plus 8 gives me 24 as well. So I verified that plugging in 4 does make all three sides congruent. All right, so last one, let's look at some things we have. Find x and y in the triangle below. Based on the markings here, I have two sides are congruent. So I know that this must be an isosceles triangle. So what do I know about isosceles triangles? Two sides are congruent. And I know that the base angles are congruent. So using the information about the side lengths, 2x minus 1 has to equal x plus 5, because that's where my congruency markings are. Solving for x, I'm going to subtract x from both sides. Then I'm going to add 1. So I get x is equal to 6. Now to find y, notice where y is located. Gives me the expression for the angle measures. B and C are my base angles. Base angles are congruent, so I set those two expressions equal to each other. I'm going to subtract y from both sides. Add 10, and I get y is equal to 20. Okay, I'll see you in class.